Now that we have talked about Coulomb's law, and we know that the unit of charge is of course Coulomb, we know that. Let us just talk about this unit of charge a little bit more. So here is our formula for the Coulomb's law. Okay, and now we are not interested so much in the direction but only in the magnitude of this quantity. We want to define the charge of 1 Coulomb. What do we mean by charge of 1 Coulomb? And that is what we want to define. So let's say that if there are two charges of 1 Coulomb each, okay, then 1 Coulomb is the quantity of charge such that these charges would repel each other with a force of 9 into 10 raised to power 9 Newton. Okay, so if I took two like charges and I separated them by a distance of 1 meter, if the force of repulsion between these two like charges is 9 into 10 raised to power 9 Newton, then I say that my two charges are 1 Coulomb each. Okay, so that is the definition of 1 Coulomb. We have defined it in terms of the Coulomb force experienced by the charges. Now this definition essentially fixes the value of K. Okay, and the value of K because of this definition comes out to be again the same. It is 10 raised to power 9. Now the unit for the value of this K are different, and that is very important that you understand that these units, it is Newton meter square per Coulomb square. Okay, that is the value of K, and the unit of K is also very important because questions on dimensions are asked lot of times on the value of this K and the value of this epsilon naught. Okay, so in some formulas, especially when we look at the Gauss law, it becomes simpler. Those formulas of Gauss law become simpler when the K, see, K is a constant, it's just a constant. It is replaced by another constant which is known as this constant 1 by 4 pi epsilon naught, where pi is our normal pi, and this epsilon naught is known as permittivity of free space. So permittivity means that it is the how much that space allows this Coulomb's force to transmit. So this permittivity, that is the definition of permittivity. Permittivity, what does it mean? It means how much that particular medium allows for the transference of the Coulomb's force, how much permissible it is to the transfer of or to the flow of Coulomb's force. This is known as permittivity of vacuum. It is a constant by its very nature, right? Because this 1 by 4 pi epsilon naught will be equal to 9 into 10 raised to power 9 Newton meter square per Coulomb square, and therefore by its very nature, by very definition, this epsilon naught also comes out to be a constant. Now another way to define the Coulomb's the magnitude of 1 Coulomb, right? So 1 Coulomb, we defined it using the force. Another way to define it is using the charge of an electron. So the charge of an electron we know is 10 raised to power minus 19 Coulomb. So if I were to take 6.2 into 10 raised to power 18 electrons, if I were to take these many electrons, then the charge contained within these many electrons will be equal to 1 Coulomb, and that is another way of defining the charge of an electron. This should be 1 point, okay, not 1 need to. Okay, so this is another way of defining 1 Coulomb. So this permittivity of free space or permittivity of vacuum, like I said, it is just another constant. And why do we, instead of K, why did we define this another constant? So that our Gauss's law and the subsequent formulas, they become simpler. This is just a constant. Again and again I am saying that. Why am I saying that? Because it is just a constant. Okay, so far we don't really have to, it has a big name, permittivity of free space, permittivity of vacuum. Okay, it is, but still it's just a constant. It signifies that the how easy it is for a particular medium, in this case vacuum, for the electric force to be transmitted in that medium. That is what it signifies. Now the value of this epsilon naught is around 9 into 10 raised to power minus 12. Okay, and both these quantities K as well as epsilon naught, you have to remember. Okay, very important. Numericals will be asked. Sometimes value might be provided, sometimes they might not provide values. Okay, especially in the latest papers, it has been seen that sometimes they just miss it. Okay, so don't forget to remember these values. Both of these values are important. Okay, and they are simple to remember, they are not that complicated to remember. And of course, this dimension is also very important. The units of epsilon naught and k are very important. Why? Again, because dimensional analysis could be asked on this. Okay, so with this we cover the important aspects of the Coulomb's law. We have understood what the charge of 1 coulomb actually means. We have defined K, the proportionality constant in the Coulomb's law, and we have also understood the another proportionality constant which is sometimes put in, which is the epsilon naught. But both the formulas are exactly the same. They are no different. Whether I write Q1 Q2 upon R square, or whether I write 1 by 4 pi epsilon naught Q1 Q2 upon R square, both formulas are exactly equivalent. Thank you.